Okay, good evening, friends. Today we will learn about the household transformation. Okay, uh, it is like a mirror image of a vector and mirror image transformation. Household transformation is a linear transformation that represent a reflection about a plane. It was described and used by Alston Scott Householder in 1958. Okay, we can say it is a mirror image transformation of an object. Let us understand this by a diagram and with the help of a practical example also. Okay, this is a diagram of image of a vector y. This is a diagram of the image of a vector y with respect to a mirror. This is a mirror. Okay, with respect to this mirror. Okay, if you want to find the mirror image of the vector y, then we take the multiplication of y with householder matrix and we can find the mirror image of y. This process is known as householder transformation. Okay, in this case, let we have a vector v. This is a vector v. This vector is a unit vector, is normal vector space, is a vector of length 1, and this vector is orthogonal to the mirror, this mirror m. This vector is orthogonal to the mirror m, that is the angle between the mirror and this vector u, unit vector v, is 90. Let we have a vector y. Okay, let we have a vector y, and this is the origin o. Let we have a vector y, and if you want to find the image of y in the mirror, then the image is y dash. This is the image y dash. Okay, this is the surface of mirror. This is the surface of mirror. Okay, in this case, the vector v, the vector v make a angle 90 degree with the vector which is attached with the vector y dash, vector y, and this vector is v Hermitian y and v, and this vector both are the both are parallel each other. This vector v and this vector v both are parallel each other, so the value of this vector is also v transpose y vector and v, but the direction of this vector is opposite, then the sign is negative. Okay, and similarly, if we attach this vector with the image of y vector, then the vector from y a to b is negative of 2 times of this vector. Okay, okay, let me take this diagram here, o, a and b. Then this vector is minus 2 v Hermitian y and v. This vector is y, and then the value of this vector is ob equal to oa plus ab, because the direction of this and this are same and this is opposite direction. ob is y, y dash. This is y dash. This is image of y. This is y dash equal to y. This is image of this is y, and minus of 2 times of v Hermitian y and v vector v. After solving this, if we take y common from this calculation, then we have a vector y, and the resultant is I is imaginary I is identity matrix, unity matrix, minus 2 v Hermitian and v, and finally we have this is, and we can also calculate this v Hermitian v by the method of v outer product p. Okay, this matrix is known as householder matrix. This matrix is known as householder matrix. If we multiply this matrix with any vector, then we can find the mirror image of the vector. This is mirror image. Okay, this matrix is householder matrix, and the process of finding the mirror image of a vector is known as Householder transformation. This is just a transformation, mirror image transformation. The householder matrix the householder matrix is a matrix which is also Hermitian matrix. Hermitian means if we take conjugate transpose of the matrix, then we can find same matrix. Householder matrix is a Hermitian matrix. This is a unitary matrix. It's mean if we want to find the inverse of this matrix, then the inverse of this householder matrix is the Hermitian of this matrix. Similarly, we can say that the household Hermitian of the householder matrix S multiply with S, it is equal to identity matrix. This matrix is an involuntary matrix also. It's mean the square of the householder matrix is 1, is identity matrix. And by this property, involuntary matrix property, we can say that the matrix has only two eigenvalue, one is -1 and other is 1. Because if we solve this by lambda square minus 1 equal to 0, then we have two eigenvalue 1 and -1. And if the matrix has only two eigenvalue 1 and -1, then we can simply say that the determinant of the householder matrix is -1. Okay, so this is the all about this is the basic concept of the householder matrix. This is just a mirror image transformation. Okay, and also we can understand it by a mirror. Thank you. This is all about the householder transformation. In our next lecture we will learn about the householder transformation, also the example of household transformation, also the practical example with the help of a mirror of a householder transformation. Okay, thank you.